This is my fifth video on my module on sketching trig functions. In this video we're going to focus on the graphs of y equals a tangent bx and a tangent or a cotangent bx, but it's a little bit different than what you see with sine and cosine. So previously we had found with graphs of y equals a sine bx and y equals a cosine bx that the period was 2 pi over b, as a matter of fact. 2 pi over b was the graph of those. And then likewise with the reciprocal functions, but the reason why we were mentioning this is because 2 pi is the original period, the original normal period of those two graphs split b ways, okay? Fact is though, when we talk about tangent and cotangent, we say that they don't have a period of just 2 pi, they have a period of just pi, okay? So what we know is this: in order for y equals a tangent bx to complete one cycle, the product bx must vary in value from 0 to, and we're going to write pi. 0 to pi. In other words, if what is inside of this value right here goes from 0 to pi, this whole thing here goes from 0 to pi, then tangent will go through one complete cycle, because pi is the period of tangent. That's how long you would have to go before it starts to repeat itself. So we say if bx varies with 0 to pi here, then we say if we were to divide everything here by b, divide, and I don't want to do this with yellow, let's go with maybe a darker shade of green. If we were to divide everything in this inequality by b, then we arrive at this. We'd say, well, then x varies with 0 to pi over b, okay? So we say if b is a positive number, the graphs of y equals a tangent bx and y equals a cotangent bx will have this as their period and no amplitude. Of course, the only two graphs that have amplitude are sine and cosine. But what I want to point out here is this: the period of tangent is the normal period of tangent divided b ways, and the normal period happens to be pi. So just remember that for sine and cosine, the period is 2 pi over b, and for their reciprocals as well. But for tangent and cotangent, it's just pi over b. Okay, so I'll read through one more note that I've written here, and then we'll kind of sketch a couple of graphs of these. But it says each graph will rise and fall at a faster rate than the corresponding graphs of y equals 1 tangent x and y equals 1 cotangent x if a is greater than 1, and at a slower rate if the absolute value of a is between 0 and 1, or in other words, if this is a proper fraction, it'll grow at a slower rate. Okay, so in terms of graphing these, here's the first thing I want to recall. Recall that y equals tangent of x is a graph that would be equivalent to this here. We say sine x over cosine of x. The reason why I mention this is because the graph of tangent of x is going to be undefined wherever cosine of x equals 0. So we say undefined if cosine of x equals 0. So here's what I know. As far as graphing tangent graphs go, what I can tell you is if you had two consecutive asymptotes, this would just be, it's like one period here. What we're after is two consecutive asymptotes, because every graph of tangent, if we were to quarter this here, is at ground level between the two asymptotes and is an ever-increasing thing. It is an ever-increasing thing. It looks like this and just repeats itself. And we'd say this value here and this value here, this would be like positive a and this would be like negative a, whatever our a value is out front. But what I want to point out is this: the graph of tangent is going to be undefined here and here wherever cosine of x equals 0. So maybe we take a look at our unit circle here. We say, okay, so where is cosine of x equal to 0 at? So if cosine values are x values, then we say, well, then cosine of x would be 0 at pi halves here, and maybe 3 pi halves it would be 0. We could say about pi halves and even negative pi halves. So I want us to kind of make a note of this. In order to graph y equals tangent x, we say step 1, identify two consecutive asymptotes. Okay, this is like the number one priority on our list here. And the way we're going to do this is we're going to set whatever's in here, set equal to plus or minus pi halves, because that would cause it to be undefined. Alright, so here's what we'll do. We'll take a look at this graph up here where we have y equals a tangent bx here, where our a value is 2 and our b value is 2. Let's start with this. We say amplitude, none. It doesn't have amplitude. We say period. Well, we'll take the normal period of tangent, which is pi, and we'll divide it by the b value, pi halves. So we say this is the period, this is the amplitude, where it doesn't have any amplitude. Okay, next we want to find two consecutive asymptotes. So what we're going to do is we're going to take whatever's in here, we're going to set it equal to pi halves, where it would be undefined, where cosine of x would be 0. So we say set it equal to pi halves, and we're going to set it equal also to negative pi halves. This is going to be the equations of both of our asymptotes here. So solving this first one, if we divide by 2, divide by 2 is the same as multiply by a half, multiply by the reciprocal, we get pi fourths. So one asymptote is going to be at pi fourths, and if we divide by 2 down here, which is really times a half here, we'd get negative pi fourths, negative pi fourths. So to sketch this graph, here's what it would essentially look like. We'll say this. We'd say, okay, we'll put on negative pi fourths, and then positive pi fourths, which are just opposites, so they split the difference here, and we'll drop in the asymptotes. So I've got two asymptotes, here they are. Okay, so we'd say take this normal period here, we're going to cut it in half, and then we'll quarter those halves. So we say here's our period, quartered. Also this, we say the a value being 2, we'll go 2 up into the air. We'll also go 2 down and below the x-axis here. We've got everything we need now really to graph this. Recall that all we needed to know were, first of all, the period, which is pi halves. You can tell that it's pi halves. It took pi halves to get from here to here, negative pi fourths to pi fourths. But also this, the a value, and two consecutive asymptotes. And we found that by setting whatever's in here equal to plus or minus pi halves. Okay, so now to get the rest of this graph, I'll just switch over to I like an orange on this one. But halfway through the period, we know that tangent is at ground level. Here it is, ground level. And then we say tangent is increasing, but with an a value of 2, if it's always increasing like this here, then we say a fourth of the way through its period, it must have been down here at negative 2, and 3/4 of the way through its period, it's up here at positive 2. Okay, so this is why on my note down here we say if the absolute value of a is greater than 1, then it's going to grow faster, because if it would have been equal to 1, it would have been here and here, and it would have looked like this. Okay, it would have looked like this, but since it was 2, then we'd say it was actually growing faster. All right. So that's the graph of tangent of x. If we were to do a cotangent, very quickly, we say y equals 2 cotangent 2x. Let's just go ahead and hammer this one out. We say a 2, the b value's 2, so we say amplitude, none. Period. We'll take the normal period of cotangent, which is pi, and we'll divide it by b, which in this case is 2. So we see the period is pi halves. Okay. So what do we know about cotangent? Hey, cotangent of x is the same thing as cosine of x over sine of x. So I know that this is going to be undefined whenever sine of x equals 0. So that would be with my unit circle here. Sine of x is equal to 0 at 0 radians and pi radians. So what we'll do is we'll take what's in here, and this is how you always graph a cotangent graph. You'll set what's in there, 2x equal to 0, and then we'll set what's in there equal to pi. And this will find two consecutive asymptotes for us. So solving this, we get divided by 2, we get x equals 0. That's one asymptote. If we split these both in half, we get x equals pi halves. This is another asymptote. So to sketch this in, we'd say, okay, well, I've got an asymptote at x equals 0. Whoops. I've got an asymptote at pi halves, asymptote here. So we'll take this normal period, we'll quarter it. So half of that is pi fourths, quarter those. We say the a value is 2, so we say 2 up in the air, 2 down here. And what we know about cotangent graphs is they're reciprocal of tangent, they're always decreasing. So with every cotangent tangent graph, we say halfway through the asymptotes here, it's always at ground level. And since it's always decreasing, a fourth of the way through it must have been up at positive 2, and 3/4 of the way through it must have been down at negative 2. So our graph looks like this. Crawls along the asymptote, goes down, and then crawls along the asymptote. So that would be that graph there. Cheers.